In this video, we are going to look at several summation formulas, and then we're going to use those summation formulas to help us to evaluate a couple sums. Now, as we look at these formulas, I'm going to try to give you some intuition so we can go through that. So here, the first one, if we have the sum I equals 1 to n of a constant times a sub I, that constant, we could factor out all of those terms, and so we can move that constant c out to the front. So if I had something like a sum I equals 1 to 16 of 4 times 2i minus 1, that 4 we could move out in front. Just like that. Great. So that is our first rule. The second rule, summation rule that we have is if we have the sum I equals 1 to n of a sub I plus or minus b sub I, we can split those up and we can group together all of the a sub I terms and add those together, group together all the b sub I terms and add those together, and then either add or subtract appropriately. Our next rule says if we sum from I equals 1 to n just a constant, then that is just the constant times n. Right? So here we have that constant. That constant doesn't change every time we update the index. It just stays the same. Right? So if I were to look at sum I equals 1 to 5 of 3, what this means is this is just 3 plus 3 plus 3 plus 3 plus 3. So I've just added 3 together 5 times. So that's just 3 times 5, or 15. Great. Our next summation rule, this tells us if we were to sum from I equals 1 to n, the value I, when you do that, it is going to add up to n times n plus 1 over 2. Right, so if I were to take sum I equals 1 to, let's say, 200 of I, this would be equal to 200 times 201 over 2. Which is 20,100. Okay, so if it's just I itself, you can take the upper index, multiply it by 1 more than the upper index, and divide it by 2. Now that's provided it's starting at 1. If it starts at something else, you'll have to be careful. You'll have to think about what things you might want to do. If we're summing I squared from 1 to n, we have almost the same thing, right? We have n plus 1. Then we have a 2n plus 1, and we have 6 on the bottom. And so here, if I wanted to sum from I equals 1 to 20 of I squared, our upper, we did start at 1. Our upper limit is 20. And so we have 20 times 21 times 41 all over 6. And if you do that, you will get 2870. And then finally we have our I cubed formula. Sum I equals 1 to n of I cubed is n squared times n plus 1 squared over 4. Notice this formula is this formula up here squared. Right? So we're squaring this formula up here. Great. So let's look at a couple examples where we are going to make use of these summation formulas. All right, so here we have an example. We have a sum from I equals 1 to 16 of 5i minus 4. So we could split this up between that subtraction and call it a sum I equals 1 to 16 of 5i minus the sum I equals 1 to 16 of 4. Right? So there we are using the second summation formula. We split up between those two terms because it was a subtraction. Now, if it was multiplication or division, we couldn't do that. But because it's subtraction, we can do that. Then, on that first one, we can bring that 5 out in front. Perfect. And now what? So on this piece right here, we have that 5. Oh, that should be an I there. So what do we do when we have a sum of I from 1 to 16? Well, we take that upper limit, and we multiply it by 1 more than that upper limit, and divide by 2. So that will be the sum I equals 1 to 16. And for this other piece right here, what do we get when we add that up? Well, that's a constant added to itself 16 times. So we have just 4 times 16. And when we do all of that, we end up with 616. So that's how we can use those summation rules to evaluate sums. All right, let's look at this next example. Here we have the sum I equals 1 to 140 of I times I minus 1. Now you might be tempted to break it up immediately. However, because of the multiplication, we can't do that. So let's distribute through first. This would be I squared minus I. Now we could split it up between the subtraction. So we have I squared minus the sum I equals 1 to 140 of I. And now we can use our rules. So for I squared, let's turn back and look at that rule. For I squared, our rule was right down here. It is n times n plus 1 times 2n plus 1 over 6. It does need to start with 1. Let's just verify that. Here, our summation does start with 1. And so we'll have 140 times 141 times 2 times 140 plus 1. So that would be 281. And that is all over 6. For the other piece, we have 140 times 141 over 2. And so we can turn back and look at that summation rule again. So for I, starting at 1, ending at 140, for summing I, starting at 1, ending at n, so our value of n is 140. So we have 140 plus 141 or times 141 over 2. Right, 140 times 141 over 2. And if we evaluate all of that, we get 914,620. And we are able to add those 140 terms together really pretty quick. Much quicker than if we went one by one, one at a time. All right, come on back for our next video, and we will look at some more summations, and we will see you there.